Have you ever wondered how our electronic gadgets work? How do they seamlessly perform complex tasks? The answer lies in tiny components called resistors. They are the unsung heroes of the electronic world. Resistors are like traffic regulators in a bustling city. They control the flow of electricity in circuits. Just like traffic lights ensure smooth traffic flow, resistors manage current to prevent damage and ensure optimal performance. Imagine a world without resistors. It would be chaotic. Circuits would overheat, components would fry, and our gadgets would be nothing more than useless pieces of metal and plastic. Resistors are essential for the proper functioning of almost every electronic device we use. From smartphones and laptops to televisions and refrigerators, these tiny components play a crucial role in shaping our modern lives. They are the silent guardians of our electronic world, working tirelessly behind the scenes. Resistors come in various shapes and sizes, but their basic structure is surprisingly simple. Imagine a ceramic rod wrapped with a thin film of resistive material. This material is typically made of carbon, metal film, or metal oxide. The type of material determines the resistor's resistance value. The resistive material acts like a bottleneck for electricity. It restricts the flow of current, converting some electrical energy into heat. Think of it like a narrow section in a water pipe. The water flow reduces as it passes through the constriction, and some energy is lost due to friction. At the ends of the ceramic rod are metal caps with wire leads attached. These leads act as the resistor's legs, allowing it to be easily connected to a circuit board or other components. The entire assembly is usually coated with a protective layer of paint or epoxy resin to shield it from moisture, dust, and other environmental factors. Resistors are everywhere in our daily lives. They are found in almost every electronic device imaginable. In a simple light bulb, a resistor limits the current flowing through the filament, preventing it from burning out too quickly. In a smartphone, thousands of resistors work together to control various functions, such as adjusting screen brightness, managing battery charging, and filtering audio signals. They are also crucial for temperature sensing, signal amplification, and data conversion. Resistors are even used in medical equipment, automotive systems, and industrial machinery. From pacemakers and X-ray machines to car engine control units and robotic arms, resistors play a vital role in ensuring the accuracy, reliability, and safety of countless applications. Why are resistors so important in electronic circuits? They provide several key benefits that enable designers to create complex and reliable devices. One of the primary advantages is current control. By carefully selecting the resistance value, engineers can precisely regulate the amount of current flowing through specific parts of a circuit. This control is essential for protecting sensitive components from damage due to excessive current. Resistors also help to divide voltage, ensuring that each component receives the appropriate electrical potential for optimal performance. Imagine a power strip with multiple outlets. Each outlet receives the same voltage from the main supply, allowing different devices to operate simultaneously without interfering with each other. Resistors are like the unsung heroes that ensure the smooth and safe operation of our electronic gadgets. Their ability to control current, divide voltage, and dissipate power makes them indispensable components in the world of electronics. Section 5. The limits of resistance, heat, and power capacity. While resistors are incredibly versatile, they do have some limitations. One of the key challenges is heat dissipation. As resistors restrict current flow, they convert some electrical energy into heat. This heat generation can be problematic if not managed properly. Excessive heat can damage the resistor itself, leading to failure. It can also affect nearby components, degrading their performance or even causing them to malfunction. To address this issue, resistors come with power ratings, which indicate the maximum amount of power they can safely dissipate without overheating. Engineers carefully consider these power ratings when designing circuits, ensuring that resistors are chosen to handle the expected power levels. Heat sinks and other cooling mechanisms may also be employed to dissipate heat effectively, especially in high-power applications. Section 6. Decoding Ohm's Law, the voltage-current resistance dance. To understand how resistors work, we need to delve into the fundamental principle that governs their behavior, Ohm's law. This law, named after the German physicist Georg Simon Ohm, describes the relationship between voltage, current, and resistance in an electrical circuit. Imagine voltage as the force that pushes electrons through a circuit, like the pressure that pushes water through a pipe. Current is the flow of electrons, similar to the flow of water. Resistance, as we've discussed, is the opposition to this flow, analogous to the friction inside the pipe. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage applied across its ends, and inversely proportional to the resistance of the conductor. In simpler terms, if we increase the voltage, the current will increase, and if we increase the resistance, the current will decrease. Section 7. Ohm's law in action, a simple calculation. Let's consider a simple example to illustrate Ohm's law. Suppose we have a circuit with a 12-volt battery and a resistor with a resistance of 4 ohms. What would be the current flowing through this circuit? Using Ohm's law, we can easily calculate the current. Current I equals voltage, V, divided by resistance, R. I equals 12 volts divided by 4 ohms, which equals 3 amperes. Therefore, the current flowing through this circuit would be 3 amperes. This simple calculation demonstrates the power of Ohm's law in predicting and understanding the behavior of electrical circuits. By manipulating the values of voltage and resistance, we can control the amount of current flowing through a circuit, which is crucial for the proper functioning of electronic devices. Section 8. Beyond Ohm types of resistors and their special talents. Just like a diverse team with unique skills, the world of resistors offers a variety of types, each with its own special talents and applications. We have fixed resistors, the steadfast members, always maintaining a constant resistance value. Then there are variable resistors, the adaptable ones, allowing us to adjust the resistance as needed. Imagine them as volume knobs on a stereo system, smoothly controlling the sound level. These variable resistors, also known as potentiometers, find their calling in audio equipment, dimmable lights, and various control circuits. Thermistors, the temperature-sensitive members of the team, change their resistance with temperature fluctuations. They are the vigilant guardians in digital thermometers and thermal protection circuits, ensuring safety and accuracy. And let's not forget about photoresistors, the light-sensitive ones, whose resistance varies with light intensity. They play a crucial role in automatic streetlights, camera light meters, and other light-dependent applications. Section 9. Resistors, the unsung heroes of the electronic age. In the grand symphony of electronics, resistors may seem like humble players, but their role is paramount. They are the unsung heroes, quietly working behind the scenes to ensure the harmonious functioning of our electronic gadgets. From controlling current and dividing voltage to dissipating power and providing specific resistance values, resistors are the backbone of electronic circuits. Their ability to precisely regulate electrical energy makes them indispensable components in countless applications. As technology advances and electronic devices become even more sophisticated, the importance of resistors will only continue to grow. These tiny components will continue to play a crucial role in shaping our electronic future, silently and reliably performing their essential tasks. So the next time you use your smartphone, watch television, or even turn on a light, take a moment to appreciate the unsung heroes that make it all possible. The resistors.